the spring occurs at the top of mountains. And this is where we come now a bit more to discuss the temperature gradient, because the temperature gradient is absolutely vital for fertility. Under positive temperature gradient, that means that the air is warmer than the ground, or the rainwater temperature is warmer than the ground, that the rainwater will infiltrate, and as it does so, it takes all the salts down to just above the main groundwater body, the 4 degrees centigrade part, where the salts are precipitated out. Because Viktor says that under darkness and the exclusion of light and the exclusion of heat, precipitation occurs with cooling, so that the colder the water gets, once it gets to its most dense condition, it has no room for these other elements in it, and it chucks them out, and so they sit just above it. When you cut down an area of forest, though, then a certain amount of the ground gets warmer, so that the rain falling on it then doesn't penetrate. The result of this is that there is less of an overburden of water above the groundwater body to counteract the geothermal pressure from below. So that part of the water table gets shoved up under the place where the forest has been removed, and brings up the salts with it. Now, in an extreme condition, as occurs here, then the salts all come to the surface, and you have serious problems of salination. So if that's why it's very important that there should always be a good balance of forest and open space, and even in all agriculture, certainly. And the effective also of forest and belts of trees is to contain the carbon dioxide, which is after all which is transformed into growth through photosynthesis. If the carbon dioxide is not there, is swept away because there is not enough trees, then the growth that occurs is not as high quality. There are situations, however, where there has been massive deforestation, and the only way to return the river to its normal healthy state and to bring the groundwater back to recharge the groundwater is to plant trees on each side of the river, because then the river will become cool, but also the ground temperatures around the river will become even cooler. And as heat always moves to cold, whatever water is in here will be sucked into the surrounding soil, and in the process will take all the salts shown, so dotted here, away from the surface, which will enable other trees and other life to develop. It also will bring the groundwater up, will also be recharged. But this is very critical in terms of what we are doing with rivers, because here again we have a situation where the ground is cool, but it's cooler than the river, so the river acts as the nutrient transport from its source all the way along its length, and as it moves around bends and so on, and we'll discuss it a little later, it grinds up gravel, it grinds up the various rocks in its bed, and these it then dissolves, and it enriches itself with nutrients. And a condition where of a positive temperature gradient, the water of the river will then flow into the surrounding soil and revitalize it or recharge it with minerals, and also the groundwater table. On the other hand, though, if the trees have been removed and the water then becomes cooler than the ground, because ground without water in it heats up much more rapidly than ground with it, then whatever moisture and nutrients are in the ground get sucked into the river, and so the ground becomes impoverished because the trees have been taken away. A different situation occurs when, for instance, you have a shaded side of a river and a cleared side of the river. On the shaded side, the profile then becomes asymmetrical because the water is cooler on the shaded side. It has a greater ability to shift gravel and sediment. But on this side, the temperatures will be cooler than the water, on this side hotter. So in this situation, the river actually acts to transfer the nutrients from one side of the river to the other one. Now, water in its natural flow always wants to move curves, in sinusoidal forms, to sway backwards and forwards. And even these are two diagrams taken from a book of hydraulics, where the water was put in a straight channel and some sand put in, and even in this, so to speak, straight jacket for the water, which likes to move, these meanders were formed. And so that was the natural way that water likes to flow. But the flow of water is governed by temperature, and very, very subtle differences in temperature. Presently, the differences in temperature, which may be as little as 1.5 degrees, are considered so insignificant in conventional hydraulic engineering and river engineering that they're totally discounted. But it's precisely these temperatures which are important, and they determine whether a river will pick up sediment, transport it, and deposit it, and whether in fact the river is going to flood or not flood. Now, as was mentioned a long time ago, relatively speaking, every particle of water is associated with a certain temperature and a specific velocity. And here you can see at the top the velocity curve of water. The cooler the water, the faster it flows, and the longer it flows over a given time interval. So all these different lengths of arrow represent waters at different temperatures and the distance they have all flowed in the same time. And from this you get what is called a velocity curve. Now, once each particle of water in these various skeins or horizons of water has exceeded its critical velocity relative to its temperature, then turbulence occurs, so to speak, and it causes spirals to rise from the bottom upwards. And that is why when you see in rivers, many of the ripples break backwards, because the water has exceeded its the velocity according to its temperature. But these are valuable things because they break the water's flow, they stop it from going too fast, and they also act to distribute nutrients to the right and left of the water course. But what happens in rivers is there's a series of temperature gradients where they alternate from positive to negative. Now, under normal situation here, this shows how this alternation occurs. Under negative temperature gradient, whatever is carried by the river is gradually deposited until the maximum point is reached here, which creates an overfall. Now, at the overfall, the water falls over and a horizontal vortex is created. And in the middle of this vortex, the water is identifiably cooler, because water cannot move into a vortex without automatically cooling at the same time, because the densest water always resides in the middle of the vortex. So at this point then, instead of a negative temperature gradient, we have a positive temperature gradient, because the water is now in a cooling direction and not in a heating direction. And as a result, it's able to pick up more sediment, grind it and scour it, and transport it. And gradually, as it moves, it transports sediment, and then it gradually turns over to a negative temperature gradient. It becomes warmer due to the sun, due to sort of frictional forces, and it drops its sediment again. So you have this sequence of positive, negative, all the way down a watercourse. But if you disturb them, because you could, for instance, the river was flowing through natural forests and you take the forest away, then suddenly you have a succession of negative temperature gradients, which means that everything is dropped all the time. There's no carriage there's no deepening of the bed, there's no transport of material, and so you have a flooding situation. And I think probably this has been happening in the state of Washington recently for the same sort of reasons. Viktor also, in his he developed a system of making water flow in this vortical manner, longitudinal vortices in pipes, because most of the pipes that we have for use in water mains and so on are just straight pipes. They're cylindrical pipes, they've got nothing in them. Viktor installed these veins, like sort of fluted veins like this, which the function of which was to cause the water to turn into a vortex inside, and in that way, again, firstly the vortex is this energizing process, it's also a cooling process, and it enabled the water to pass through the pipe much faster.